Okay, so this is lab number 9. Okay, and we try to see just to go over to make sure you know the way how the circuitry working. But before we try to go into the detail, I will be asking you, no matter what, you have to know if you get a new project, then you have to know how to create your new project, okay, in the Visual C++. Then you know how to copy the previous program and you can edit it, okay? Now, this is a very easy one. First thing they can try the data, U1, go to U3, then they enable U2 and verify data 1155AA. That's the first two tests. Anything wrong on those two tests, they can be U1, U2, U3, and also U4. The second two tests sort for the same data, 55 and AA. That means they will be sent a 55 go to U1, U2. Then they will be enable U6. Then enable U7. And they read it back. So anything wrong on that number 3, they can be either U6, U7, U4, U9, and U8. U9, not U8, okay? That means after you pass the first two tests, then the next test, if there is something wrong, they can be U6, U7, U2, U4, and U9, and U10. That another test, number 4, will be the same, but the data will be AA. And the data will be AA on test number 4, some wrong. They should be U6 or U7. Something wrong with U9 or U4 or U10, they must be failed at the test number 3. And the last one, test for the memory here. So basically for memory, you need to apply address. Then you have to apply the data. Then you can write it to the memory. Everything already inside the function. Write address to memory, or write data to the memory, or write to memory. So now you can see how they work. If you want to apply address, data will be sent from U1 to U3, then now you have to latch to U5. That means the data will be going to here. Okay, that's the address. And when you want to writing a data, same thing. Data will be go from U1 U3, and now go to U6 and go to U number 8. Okay? Then you can apply write. Then the data will be go into that location of the memory. Normally you have to write 2 times. After you write data 55, and now you change data to AA, but you get a different address. Okay? And when then you can read. That means you have to apply a reading to the memory. And the data coming out, they go into here. Then they go U7 and go back to U2 and verify. So on the test for memory, something wrong. They can be U5. They can be U number 8. And also they can be U number 10. Nothing to do with U6, U7 or U9. Okay? And also in here, you get the last here, they go to U4. So for the first 2 test memory, some wrong. They can be U5, they can be U8, they can be U4, okay? Or they can be U10. That's it. And everything I already given to you in the program in here. On of the function prototype. And this is a function definition. Okay? Then that's why you're able to coding your program. And also in your program, they're telling you they want to test, okay, for even address with 55 data, odd address for data AA. Okay, so normally you can get X128 test. Okay, 4 times of the 128 test. So basically, you get 256, okay, to verify. However, in here I say, you reading, you increment by 20 to make your program shorter. Instead, increment by 2. So that takes a lot of time. So right now, if you not completely understand the circuitry, at least you have to know how to create your project, typing in on of the function prototype or decoration. Then you have to typing for the function definition here. Before you can typing any text into your program. Normally, I want you guys to do. You see that? You can copy that thing here. I already did it for you. Okay? Paste it into your program. Then you can start void main. Okay? And you can copy that thing I already given to you. Okay? And you can copy that number 1. Okay. Then you have to go into the end man, right here. That means you have to get this line here, and man. Now, you can type in the function definition for each one. Okay? And then you have to do all of the function definition. In here, I given to you only not much. Okay? And you have to do it. If you get a problem, you can text to me. I on Zoom to help you out. You get through the text queue. This is the key point. Okay? You must know how to do it.
Mr. Pham, one question.
Yeah, go ahead.
Okay, you said that we are going to test 8 wires, an input-output wire, and 256 locations. So still it's not clear to me how the 43 hex numbers that we're going to test related to those 256
Okay.
addresses that we're going to test.
Okay, if you're looking into the schematic.
Okay.
This memory.
Yep.
Basically, they get how many Y address?
Those are 11.
11. Okay. But we're not using all.
Yep.
Only 8 wire.
Okay.
So when you get an 8 wire, to know how many locations? 2 power of 8. 256.
256, yes.
Location. Each location get 8 bits of data.
Okay.
Okay. So the first thing what we want to do, we want to loading apply the address 010101. And we apply the data 101010. Okay? That
okay.
Address and data will be opposite. So we can drive that data into that location. Okay? Then next we'll be loading another address, AA, and the data 10 into 55. So we're loading into that location. After you loading data into different locations, now we will be reading and verify whatever you put it in to that location, they will be the same. Okay?
Okay.
That guarantee on of the wire here and the wire here, you have a no problem. Okay? And
okay.
later on, they get total to 56 locations. And normally, if you're loading to location 0, then I want data to be 01010155. Then you're loading to the location 1. I want the data to be AA. That means your location get a different data. That's what you have to do for total is 256 locations. After loading everything, then now you can read them back to verify. Okay, if you're looking into the software here, okay, let's see. Just a minute, I show you. Let's see here. Start reading even address. So before that, and now they say write data to even location. So you're going from J0 to 256. J increment by 2. That means the first location will be 0. The next location will be 2, 4, 6, okay? And you write the data, okay? 5, 5, okay? Into that location, okay? You see that right here. Write data to memory 5, 5. So inside here, you said write address to memory per J. That means J will be equal 0, 2, 4, 6 to 56. You write data into that. That means completely on that line here. You already write 5, 5 to even location.
Yeah, but okay, but that is the half of the 256, right?
Right. Now, then they say, okay, write AA to the odd.
Yep.
So you write outside the loop, write data to the memory AA. Then now you're using the loop for J equal 1. Add them to 56. J plus 2. So you start with J equal to 1.
1, 10, 3, 5, 7.
Exactly, until 255.
Yeah.
So after you're done, up to this point, data already filled, both even and odd.
Yeah.
Okay? Then now you say, start reading even. And the data you loaded in is 55. Okay? So now you say expect data. You want to be 55. And you're doing the loop the same. 0 to 56, okay? And increment by 2. However, in here I increment by 20th.
Yeah.
Make it shorter. Okay? Random reading. Then you can write a thread per J. And now you read, then you verify. That means they will be go into even 0 to 4, 6, so on to get the data. When you're doing in the class, they will be not 20th, they will be 2. So they will be reading 128 locations. And after you're reading even, now you go to reading odd. Okay? And the data you want, they supposed to be A, okay? Right here. And do the same thing. J1 less than 256, okay, the plus 2. So they could be 1, 3, 5, so on. So after they done for this part here, that means they already verify 128 locations for odd. So you get a total 256 tests, right?
Yes.
Okay. Then now you repeat exactly the same. Only they want to change. Instead you say before data 55, now you change to AA. for the even. And for the odd, you change data to 5. Okay? Then you reading and verify. And you get another 256 tabs. Total will be 512 for that even and odd location. Check for a while. Okay? Basically, in here, I only given to you. So that's why. Just copy exactly into your program. Normally, if the IC is good, that means they can pass the test before you can test the odd or even. Then no problem for testing odd or even. Only thing is the IC itself, they get some wrong inside. Then they can be failed.
Okay.
That's a completely testing for the memory.
Yeah. And could you show please the line number 20 of this document?
Line number 20.
Yes.
From the program of,
Yeah. Go up.
okay.
Yeah. So number 20, you on number 20 you declare integer ADC data 43, and then you have also 43 hexadecimal numbers.
Okay. That will be take your guy later on this one.
Okay. This is not for now.
Okay, not for now. The thing is,
Okay, got it.
Given you everything. Only thing I can tell you, that's what I using array to store the data. That means they go at from array, location 0, 1, 2, 3, 4, go on to store that data. Okay, and also array, okay, for the value. Okay, you want it.
Okay. And
that's okay. Okay.
Just of curiosity, what is the meaning of that array, Mr. Pham?
Yeah, array.
And yeah, but
you understand in the C++, we already have a chapter introduction.
Yep.
The second chapter we need for now, that's the function.
Yep.
Okay, the next you will be learn an array.
Okay.
The next will be structure. That's a minimum thing you need to know in order to do your digital lab.
Okay.
Yeah.
Thank you.
Thank you.
Thank you.
Anything else? Okay, if it's not, I go over for you the DLAB number 10. That will be more easier. Okay, that's very simple. Not complicated like the other one. Okay, first thing, you can see in here, memory right here. Who can tell me what the size of the memory? Like 1K by what? Or 2K by what? Which one is it? This IC will be RAM 2114. By looking into the schematic.
It is a 4K?
That is the memory right here.
Yeah,
Okay.
4K.
Now, I want to know what the size of
4K, 4,000.
It's 256.
Tell me, how many K by what?
4K.
Cannot be 4K. You know how many address to get?
Oh, sorry, 1K, 1K.
Fine. I'm telling you. Address.
1K times 4.
Perfect. Okay. Address, you get 10, right? 10 lines. You right? You see my notepad?
Yes, we see it.
Okay.
Yes, sir. 10 lines.
10 lines. Okay. And a data
4
will be 4.
Yeah.
Okay. Now, if the 10 line for address, okay, the size will be 2 to the what power?
10.
Power 10, right?
Yes.
1024.
Okay, 1024. Okay, right? That means 1K, right?
Yeah, 1 point, yeah.
1K by,
Yeah, 1K, 1K.
is it 1K by 4?
Yes.
Perfect. At least, you know, we already learned the memory. When you see how many wire for address, how many wire for data, then you're able to know the size. That means
Okay.
you get 10 wire for address and 4 wire for the data. However, on this lab, they're not using only 10. You only 8 wire. Right?
Yeah.
Okay.
From 0 to 7, yeah.
So the location to test will be 256.
And Mr. Pham, can I ask a question?
Yeah.
On the where you got size at and 1K by 4, that's where it was 2 to the n and n was 10.
Yeah.
Can you write just to the side there 2 to the n and n was 10 so I'll know?
Okay, so you want
Just put 2 to the n and then n is 10.
Okay. You want 2 to the power n.
Right.
Power 10.
Yeah. So I'll remember that. Yeah.
Okay.
And that's 1024.
1024 location.
Okay. Thank you. Thank you.
You're welcome. Okay, this lab is using only 8. So location to be 10. A joule power 8. And that will be equal to 56
6.
location. Okay? So they will be limit. Otherwise, it takes too long. Only thing we want to know, how do you know to test the memory? So the process will be the same thing. That means write data to address, okay, file, and write another data to address AA, and you read. Now, only thing here, address will be using port A, pin 1 to pin number 8. So you just write to port A, whatever you want, right? AA or 55. And that go into output up to 44. Okay, pin 1 and 19 ground. So no matter what coming input, they go to the output. Okay, so that means the address already ready here. Now, the next, writing a data. Okay, you can see what did I see here? What is it? 74, 175. Okay, I can tell you. Okay, you find 74, 175. Can you tell me what is it? Okay, if you don't know, I tell you. The flip flop. Just a D flip flop.
Yeah.
And only thing is they get only 4 input and 4 output. With 4 input and 4 output. Okay, and now you can see input number 1, pin number 4, output will be 2. Okay, pin number, output pin number 3, just opposite. We don't need to using opposite. So basically, you get the apply input 1D, 2D, 3D. Then you must be apply the positive clock that connect to P clock. Then the output will be loading into the output pin number 2, pin number 7, pin number 10, and pin number 15. Okay, and this will be go into input of U4. Okay, go input here. So now if you say you want to write, that means this pin must be 0 to write. So when you get a 0 here, if they go inverter, they go to 1. That means they disable that guy. Okay? They disable. However, 0 here, they go to 2Z, pin 19, 0. That means they allow the data from here go this way and ready to go in. So they get a 4 wire here. Okay, they share. They share either 4 data can go this way or data can go this way. That is the way how to write data to the memory. Okay, so now let's see. In here, they're already telling you. So step number 1, write data 55 to address AA. Let's see, maybe that need to modify. The data only 5, not 55, only 4-bit, not 8-bit. So basically, they say address 55 okay, but data have to be 05. And the data here have to be 0A. Okay? Then they read memory address, data expect here is supposed to be 05.
This is because we are only using 8 address wires, Mr. Pham?
Yeah, you get an 8 line for address.
Okay.
05. And you read location 55. You're supposed to get 0A. They get only 4-bit. Okay, then you write even 0805. And will be write odd 080A. Then now you read even. Then you get 0805, and that will be 0808. I will be upload that one to make sure we can get the correct data. You can done this very quick. Just copy your other program memory and change that. Okay? And also you get a following function. Write memory address, write memory data, write to memory, read memory. Okay? We don't need that one. Okay? That validate. If you want it, then basically that must be changed to that validate. Otherwise, you have to using reading, foresee, whatever. test validate. Okay, that means the same thing like the other one. Okay, and this is a function here, function definition. Okay, I already given you everything. Okay, so if you want to coding for even a thread, auto thread, okay, this is the flow chart. However, you can copy same thing from the other memory program we already done. Only changing few things, okay? Write memory data, they support to be
0x05.
0805, correct. Okay, a thread will be same thing. Okay, and that will be 0x08. And the same thing, okay, you can do. Okay, so any question on this lab? This is more simple than the other one. And it's shorter than the other one. You can see in the program, we get more students. However, someone, they register or they just want to get into the Zoom to watch it, they're not doing anything. That means they cannot be assigned to do the lab when going back in the fall. Only active students will be allowed to get into the lab. And if you've not done anything on the lab, you can stay in the program, no big deal to me. You can stay into the program until I retire. Okay, you get any question? Only thing I say on this, port A, B, C, just the reference only.
Yeah.
This test only apply if you know how to do it. Okay? We don't need a pass or fail.
Okay, so we only have to write the code, right?
Right, you write the code, upload, then Mr. Pham will be run it, verify you're good or not good program.
Okay, understood.
So make sure you have to say that program. When we get back into the lab, now only thing you need to build. Then you're using that program to test. So anything wrong, they can be hardware problem, missing wire, or the worst case, the IC itself, they're not working. That's what you need to know how to fix it.
Mr. Pham.
Yes, sir.
I've got a question for you.
Yeah.
U1 is a buffer, right?
Can you say again what I want?
U1 is a buffer, yes.
I mean, what was the purpose? I mean, it's always on, signal just goes straight through. So is it really necessary in real life, that is?
Oh, you mean normally, that is the way we design.
Mr. Pham, he's talking about U1, U1.
U1, just a buffer. Okay?
But it's always on, so the signal is always passing through.
Yeah, but the thing is, signal in here may be a little weak. So
Even-
when they go to the buffer,
Okay.
they bring it up to the standard.
Okay.
Okay? That's
Okay.
the reason why we're using buffer.
And make sure that your
What's that?
5 volts and your low is at 0 volts.
Yeah, if you get a 0.6 volt here, 0.6 is not a good input, low. They want our input low or output low. They're supposed to be 0 or very, very close to 0, 0.1, 0.2 volt. If you get logic 1 here, 2 volt, when they go into the output of the buffer, we want to bring it up to 4 volt, 4.5 or 5 volt. Okay? That's why they need the buffer. Even they're not changing anything, in, out the same, but they increase more current. Okay? Bring it up to the standard logic.
The data that goes into U1 comes from the controller box.
Right.
So what you're saying is what's coming out of the controller box going into U1 can be low or cannot be correct the way you want it. So it goes through the buffer to clean it up.
Right. They make a standard logic.
Hey, Mr. Pham, one other thing I wanted to say. You've been talking about the opening back up of the lab in the fall, but you'll probably be going over that information that you gave us today again at the end of the summer, because depending on what your boss tells you, is that correct? Maybe.
What do you mean, maybe?
I'm saying the information you give us now, more than likely it's okay, but at the end of the summer, you never know how things have changed.
I understand. However, the guarantee, okay, open in the fall.
Okay.
Now, something other coming out happened. That means not us, for everyone, everywhere. What can I say?
Yeah.
You see that?
Mm-hmm.
Say, okay, now it's COVID is going up too high. What can I do?
Yeah.
But I believe they have to be open. That's what the dean told me. I have to working on giving him what the requirement, what we need, what I'm organized in the 2 room, 250, 240. The lab for the distance 3 feet or 6 feet, depending on what they want.
But we really don't need to worry about the fall right now until the summer's done.
Yeah. But I can tell you that will be done for, what going on last year, right? Up until today.
Okay.
Okay. This is a very good thing for you to really understand the theory more than in the class. So like Mr. Smith, you can say you understand a lot now, right?
Yeah. So the theory part, that's still going, because I missed the earlier part. The theory part is still going to be online?
Yeah. The thing is you cannot put about 50, 60 students into one room.
Okay.
Otherwise, we need more room for the lab. So basically, you get 1 day for lecture, 4 days for the lab. And whoever not working then you can do 5 days for the lab. The thing is, lecture will be same thing now, 5 o'clock.
Okay.
And at that time, you don't have to study again on Tech 1. You're just doing for your Tech 2. That keeps you really busy. You have to do both lab.
The spring semester end.
One will be lab 4. Another one will be digital lab. Okay, you can get any question. Tomorrow we get the final test.
Okay.
I recommend you better take it, okay? To try to see how much you understand without looking into anything. You have to be ready for interview. Question very basic, not too much formula, okay? Asking for basically, when you see through the circuitry, you can answer it right away. I don't care your rate, A or B or C or D, doesn't matter to me. Okay? But I want to help you to review, okay? When you get the certificate, you apply for the job. Only thing I think better say the final. And at that time, just go through the final. You can do without anything else. Then you can be more confident for the interview. Otherwise, review too many things. You don't know which one you want to read. And when I'm looking into that, if the company asking me about the certain number, the certain student, I can be answer. Your guy been into the program with me for a while. I can telling you, I know who can do, who's still not really good. And we can find owner of the company in the San Diego and let your guy know so you can apply. Only thing when you get a job, just email to me, let me know. That I'm really happy. The thing I spend much of my time to really help your guy understand. And if you can understand what we are doing now, go ahead, keep going to university, okay? Or college. Next 4 year, 5 year, you can be an engineering, no problem. Okay, anything else? And I asking you, okay, try to register for summer, okay?
Okay. Mr. Pham, I have a side question.
Yeah, go ahead.
Which software did you use to create these schematics?
Oh, this software here.
Yeah.
Okay, basically, I using the one from my company before.
Okay, and what was the name of that software?
Let's see, what is the name? For some reason, just a minute. It's not we get a B spy and we get the MSIM7. I think this will be an all cap.
Okay. Okay.
LRCAD.
Yeah. Yeah. Got it. Thank you, Mr. Pham.
Yeah, that cost around 10,000.
Yeah. Yeah. No, I know. Thank you.
Okay, you are welcome. Yeah, you're doing much better. So, you know,
I'm studying hard.
yeah, I think you're working hard.
Yeah, but not easy. Not easy.
Yeah, for sure. It's not easy. And
Thank you, Mr. Pham.
also in this program, Kumi good also.
Thank you.
Yeah. And also, let's see, I think I can get, let's see.
Hey, Mr. Pham, how much difference is ORCAD from PSpice?
What a different ORCAD or PSpice?
Yeah, well, how much difference is it? Because I thought they were pretty similar.
Oh, the PSpice is let what?
About $10,000 different.
Yeah, but let in the library. That means, like, you know, if I looking for that 2114, they don't have it.
In PSpice,
Right,
but they have it in ORCAD.
right, exactly. That's
Okay.
professional. Company have to deal with anything.
Right. And what about, like, say, because I mean, there's multiple of these things. Like we use PSpice, we use Multi-Sim 7. So, but Multi-Sim 7 is that's where you want us to practice learning how to use the instrumentation. Is that correct?
Exactly. You can see so different. Okay. Multi-sim, that will be training to working with the equipment. If you know how to working with the multi-sim, then you don't have a problem when you're really working on the real lab. However, PSpice more theory. Okay?
All right.
More theory.
Okay.
Okay, right now I'm working on PSpice. However, that is using by University UCSD. And that will be a free. Okay, I already downloaded. I try to play with that. That will be much better than the PSpice we have it right now. PSpice we have right now, just a very basic, okay? If I want to test the memory, I cannot run simulation. The thing is they don't have a part, okay? I hope, you know, for the one from the UCSD, if I see they can much better, then I later on will begin to using that. Okay, anything else?
Mr. Pham, do you want Mr. Hong Fan to run over the test, whether we pass or fail?
Okay, that I asking him. Mr. Hong. Hello, Mr. Hong Fan. Okay.
Hello.
Okay, you get any DLAB?
Yeah, I have.
DLAB9 to run?
Yeah, I have a DLAB9. Let me show them DLAB9 here, okay?
Okay, try to run. We can enjoy it almost the end of the semester.
Okay, let me share my window here. And I'm talking about what we're going to have is a DLAB tonight. Okay, here is my Excel. You see my Excel file?
Yes.
Okay, now I have a II DLAB9. It fell, but I want to run that too, and then it's a DLAB8 Viola. I'm talking about that after II DLAB9 run. And the first one is DLAB9 of the Kumi.
I'm here.
Okay, your lab is a file number 1, 2, 3, and then it's down too many. But I found I found the error. So I show you the now let's see. Let me run the program file first. Okay.
Please. Not good this time, Mr. Pham.
Yeah, and then I show it's how easy to fix, and then I already fixed it for you, but I'd like to see, show you it why it fell.
Okay. Okay.
Let's see. Okay, I see it fell now, and then let's see if I can run it. I just want to make sure we already see it fell, and then I show you how I fix it.
Okay, thank you.
See, it fell right at the test number 1 and number 2, and also it's down. Now I show you why.
Oh, sexy.
Okay. Now the reason it fell because this original your line right here. You put it in integer I equals 7, and then I let it greater than 0. Okay.
Yes.
Until it's greater than 0, but you need to have it equal 0 here. Greater or equal. So you're missing this at the equal line here. Okay, so now this is your line. I comment it out. And this is the one I fixed it. Okay.
Yes,
and
equal sign.
And then I build it again. Rebuild. You see my command line here, added on today.
Yes.
6 is 2, 6, 2, it's 21.
So basically, this procedure we already using.
Yes, but see,
just copy, paste them out. Don't touch it.
But somehow she missed that side, equal side right there.
More
Okay.
time. Thank you.
Yeah, but
Now
I'm saying
run it again. So this is the lab number 9 of Kunmi. And that's a simple one, so I fix it.
Thank you.
Mr. Hank Pham.
Yes.
I upload up to DLAB 8. So could you?
I have your DLAB 8. It's already passed.
Okay. Okay. But it is the Excel data sheet is empty. I mean, your Excel data sheet is empty. You only have that I provide the DLAB 5 or 6.
DLAB 9?
I provide up to DLAB 8. I complete all my tasks up to DLAB 8.
Oh, okay. I
Can you
will
see?
check
Number
on
one.
that one.
Number one, you have only passed up to DLAB 5.
Okay, wait, let me check in here because on of your program it that I have it in here. So let me check. Your name is
Marcelo.
Marcelo. Marcelo here, up here. Marcelo. 1, 2, 3, 4, and 5. And now let me check and let number 6.
Yes, sir.
Marcelo, I don't have a number 6 Marcelo in here. Let's check number 7. I don't have your number 7 here. Number 8. Look like I don't have your.
Okay, I uploaded them already, so please check the
So I will check on that one, okay? But on of the test, after I run, I save it.
Okay,
so I already checked, and then you see your name is only from 1 to 5. And I will check the most update that one after this one, okay? After we done for this, and then if you have it, I will check it and make sure everything okay. Thank you for let me know. Maybe I'm missing that part. Let's check it. I already have a shop. No. I don't want to open this over here. I open on this side here. And let me check quickly. You said you upload all at 6, 7, and 8, right?
Yeah. Yeah.
Okay, wait for me. I have it here. Okay, I have, you have 8. You have 6, but you don't have a 7.
Okay.
I see 6 and then I see 8. Okay.
Okay,
and
I'll update again this night.
Okay, and then left 9, 8. No, not yet. So you have a 6 and 8. So I missed that too.
Okay, thank you.
And this is Kunmi is lab number 9, and the next one I'm going to show is the lab number 9 of Mr. Let me see who it is. Lab number 9, lab number 9. Oh, lab number 9, Kemchuk, okay? And also it's an easy fix, so I will show, and then I will show how I fix it for you. So you don't have to upload again. but after this one, okay?
But they have to know that program they save in their computer.
Huh?
But they have to get that program to save in their computer.
Oh, I after I run that part, I save it on my own folder, all of them. So I have a backup for all of the test parts, okay?
When they get back into the lab, they have to get the program to run.
Yes, I will bring that with me when we have it in the lab.
Now we don't need to run even or odd.
So you think this one, we can stop this?
Yeah, just after ADC, then stop it.
Okay, so Kumi, your lab
Yeah.
pass now, okay?
Thank you.
Now I'm going to upload it, Chemchuk program. That number 9, DLAB number 9. Okay, here we go. This one is
instead of Boston having a chance to cut it to single digits, they overturned that call. Harden got an and one, and then they've been on a big run since.
okay. This is your update, and then I think it.
Make sure you guys want to talk, turn on your microphone.
Thank you, Mr. Pham.
Yeah, the thing is,
Ask your brother if he had his basketball game on in the background. That might have been him. Because you can't hear him right now. He's silent. So
He's watching my Celtics lose.
hello, Mr. Pham.
yeah, his mic is muted. I think that was coming from him.
Man.
He's watching Adams Celtics win.
Hello.
Yeah,
Hello.
back.
Okay. Now it's Mr. Chemchuk. Your lab is file number 5 and number 6 and later. Okay, so I run it fail, and then I show you why it fell and then how I fix it for you. Okay. So this is the file, the update of Mr. Chemchuk. And now I'm going to run the one it passed after I modify it, and I show you where it okay. This is the one it fell, and let me go down to where it fell, and then I show you. It's 2 places. You see, this is the serial is the 2-bit. It fell because you have this line right here. This is extra. Okay, you don't need that one in there. You don't need the enable U3. You don't need the write port here. And this one have to go into the write to memory.
To be fair, that was written into the Excel sheet, so that
should be in here. It's not in the serial. Okay, and now I going to load the correct one, and then I show you where I fixed it. See, this is serial, right? I comment out the 3 line right here of yours. And then I go into the right to memory address. I add this one in there. That is the 2 places to correct your program. But this is already in the procedure. All what you need to do is just to copy and paste it in and you use it. You don't need to do anything. Anyway, I rebuild and then I will run this one for you. This is the lab number 9, DLAB number 9.
So many pieces missing throughout the year. That's been the case for most of the regular season matchups.
Why it's a hot, it's a mute to everybody again and again?
Right, still noise.
I think you can hear your basketball game in the background. You need to turn your basketball game down.
You have to turn off everything.
Okay.
The Boston losing anyway.
Since cancel it's your program right now, it's a testing ADC data. And if this one passed, that means everything okay. And then you got the credit for it because it's simple. And then I fix it for you. Okay, that's all what we have for the lab number 9.
Mr. Pham?
Yes.
I actually uploaded my DLAB 9 before class. So it's on the website.
Oh, you already, okay. But anyway, I will take a look at that. But you got the credit for this. Okay, and now I'm going to show you another lab.
Mr. Pham, just a moment.
Yes.
On this one, the line 419, you said you added that in. I believe this would run without that line being added.
Which one?
The one that you just added when you write in memory.
Why do we
for 19?
Yeah.
Okay.
If you comment that out and run it, I believe it will still run. Comment that 419 out.
I don't think it worked, but it's
comment it out.
Yep.
And then try it. I believe.
That's all.
Yeah.
Remember, I already it's a comment now at the 3 line right here.
Okay, let me check.
Okay. Okay, it's at your request. I will rebuild and run it for you, and you will see.
How come we comment that out and they still pass number 5?
Don't know yet. Depends. I have to look back into the schematics.
You enable that 2 line above that already.
Yeah, it's already enabled up there.
Right. So that's why I said last time in class, I asked Mr. Pham, and then he said he just repeated by mistake.
You can stop this one.
Okay. Okay, we stop it here. And if we are going to comment out this line, so we enable up here. So the U3 already enabled.
Right, so you do not to add another enable again.
Okay, we'll check it back on the schematic later. Or I have to run the whole lab. Okay, but anyway.
Okay, the thing you already enabled line 1417.
Yep.
And don't have to worry.
What he's saying is,
understand, yes.
Line
Understand.
417 and 419 are exactly the same.
Yeah. Okay, so now I'm going to show Mr. Let me see. So so here you got it passed. And then now I run number, I have a 2 lab to run. It's a lab number 8 and lab number 6. Mr. Kemchuk, I wanted to show lab number 6. Okay, lab number 6 is easy fix. So I'm going to show that, and then you will see it right away why it fell. This is the lab number 6 and the simple mistake. But I want to bring it up and then I show you why your lab it fell. And maybe we don't need to run it, but we have a hardware here. So I also to run a lab to make sure it fell. And then I point it out. Oh, lab number 6. No, this one is not us. Okay, this is the lab number 6 of Mr. Marcelo. You're still there, right?
Yes, sir. I'm still here.
Okay, Marcelo is still there. Okay, I'm going to the first one is I pointed out first. You see your program here? Test number 1. Okay, test number 2, it fell. Test number 3, it fell. And let me build it, and then I show you when it's built, okay? That number 2. That is, you have a P clock. You perform a P clock before you write the data in, so that's why it fell, okay? And then that number 3, you do the same thing, P clock before you write the data control data here. That is it failed. That 2 that it failed, okay?
Sorry, P clock should be immediately after.
Yeah, after to apply.
I forgot to connect to the controller. Okay, do it again.
You have to write port A or B, whatever, before you apply the clock.
Okay, okay, got it. Thank you.
Otherwise, when you apply data, clock already done.
See, that number 2 fell. That number 3 fell. Okay, now I'm going to fix that for you. So the PK clock here, that number 2, I copy that, I put it down here.
It's got to go after line 53.
That is the 1. And then another one is right here. That's all.
You have to remove that P clock.
Line 65 need to be commented out.
Mm-hmm.
And we run the test again.
Mr. Pham, you got to comment out line 65. Okay, still work.
Yeah, it's still working. The thing is, you apply that clock for nothing.
Yeah, I understand the point. I'll fix on my side too.
Okay, that's good.
You're saying that the clock has always got to be after write to port D or write to port A or whatever.
Right. You have to apply the in data first. Then the clock will be taken into the control.
Okay.
Okay. So Marcella, you got the credit for the number 6.
Wonderful. And could you please test number 8?
And now I have one more test of Miss Viola. You still there? Viola, test number 8.
Yes, I'm still here.
Yeah, Viola look like working a little harder this time.
I've been trying my best, Mr. Pham, but I'm still have a lot to go.
Right.
I'm gonna be with you for the next 2 years, that's for sure.
Me too.
Yeah, you want to be a real technician. Have to be really understand what you're doing.
They want to be lifers.
They follow you, Mr. Smith.
We're following Mr. Smith. 5 more years to go.
Mr. Smith now is very good to me.
We're retiring in 2034.
Yeah, that's why, you know, the guy want to learn. That's why I still want to teach.
Thank you.
Now start without
Now
the
I'm going to run DLAB number 8, Viola. Okay, so you start from a task number 2 and going down and continue fail. And then when I'm checking your program, I see this is a simple mistake, but I don't want to change all of the correction for all of those tests because too many. And now I show you where the mistake is, okay? Number 9, number 2. Here, you expecting data is 55, but you write in it AA.
Oh.
Okay, that is one. Number 3, you expecting 5 and 9, but you write in 55. What that is? Now it's more in here.
Oh my God.
That's
Okay.
number 4. You expect 6, but you write in 55. So look
I think
like
I
to
keep
me when
copying
you
and
copy
paste, and I just forget to change them.
you forget to change in the data, okay?
Yeah.
So now every time when you cut and paste, just one test at a time, okay? Make sure you need to have the expect data, control input, that is the write in or the data in port B, port A, whatever it is. Make sure it's correct with your Excel.
All right, I'll go fix it right now.
Yeah, this is a lot. So
right.
you have to go back and review and correct it, upload again, okay?
All right, I'll do that.
Whatever your expected data is, that's what should be inside your serial data to bit 1.
All right. Thank you.
Okay, so it's anything else?
Mr. Pham, do we have time for you to check my DLAB 9 that I uploaded earlier today, just so I don't have to wait a week to see if I passed?
Go ahead and do it.
DLAB 9, you are Ken Suk, right?
No, I'm Adam Paulding.
They twin brothers.
Oh, Adam Paulding?
Yes, sir.
Okay. That is, we will have it and quickly check.
Thank you very much.
Let me see if I can find, okay? Paulding Adam here. Number 9. Number 8, number 9. That is the only one, number 9, right?
Yes, sir. This will be my first attempt at it.
Okay, your first attempt. I can check it for you. But I have to change my hardware. Okay, but anyway, I can do it quickly for you. Make sure your name is correct. Yeah, okay. I build it, and then let's say I go to change the hardware, and then I check it for you.
And you can see I commented out U7 output enable because you really don't need it to run the program the way that the rest of the program is written.
Okay, it's ready now. We can run. So you see it fell, right?
Yes, sir.
Okay, so let quick check. Maybe the same problem with another one, but let me do a quick check here. No, nothing in here. That's that number 1, that number 2. Let's see.
Test number 2 pass.
It failed on what, 3, right?
Right. Test
It failed test number 3.
Right.
Go to test number 3.
It
Go to
not
test.
it here. It failed number 3. It read nothing here. It read only.
He says scroll
Okay.
down and test number 3.
Number 3. What is the test U6, U7 here? What? What you have something? Let's check it out. What you do in a U6, U7 test here? Procedure here. Enable U3, U6 clock. Serial data, what the data in there, what you put in the data. Test number 3. That 5.5, but it, no. I don't know yet. I have to go back and look at it. But you are doing a different with another program. That is your different way, different setting. Okay. Pauline, you with me?
Yes, sir.
Okay, so I have to take time and look at your test and see what's wrong.
Okay. Thank you very much.
You're welcome. And this is your program. I got it, Mr. Pauline, the lab number 9. Oh, very good. Anybody else? Question?
Can we check number 8, Marcelo?
Number 8.
DLAB 8, Marcelo.
Wait for me. Let me save his program first. So now, Marcelo, you said you have a number 8, right?
Yes, sir.
Let me check, and I will check this at number 8, but I didn't see it. You're there. So I have to check on the web and then download that, and I check it for you.
Adam's still here.
Yeah, he's here.
Yeah.
Adam Paulding.
Yeah, Adam.
Yes, sir.
You on your test number 3.
Yes.
You have to call the function U6 output enable.
But so here's my question about that. Immediately after U6 output enable, we are writing to port B0x21, which enables both U6 and U7.
Exactly. The thing is they drop it around.
Right. So I was Zooming with Sam and he actually ran it the way that I had written it, and it passed on his end.
No, no way.
Actually, on mine, I wrote on test 3 and test 4. One is where I used the test U6, U7. And then on test 4, I used the U6 output enable and then U7 output enable.
So
then,
we don't need the U7 output enable.
well,
Right.
If you do it separately, then yes, you do.
Yeah, when you're writing to port B to 1, they take care of that also for U7.
Right, if you use test U6, U7, the function, then yes, that will take care of both. If you do that, you do not
Marcelo?
You do not need U6.
Yeah, I'm here.
I have your lab ready. Let's run it now.
You must be get after U6 clock, then you must be get U6 output enable.
I don't understand.
I disagree with that because
why you not understand? The thing is when you say U6 output enable, that means you allow the input of U6 to go to the output of U6.
Right. But to do that, we write 0x01 to port B. And then immediately after that, we write 0x21 to port B.
Okay, the thing is 21, that means the output already on the output of U6. 21, that means they will be telling you, they wrap it around. They try to set the U9.
But I did it with, like Adam did with test U6, U7, and without the U6 output enable, it works.
Yeah, and so, again, when I Zoomed with Sam earlier today, he ran it on his end and his test passed using the same method.
Hey, Mr. Pham, right after he does Marcelo's, maybe you could put Adam's back up on the screen.
Wait a minute, I got an error on the Marcelo here. Syntax error, link syntax error, but I don't believe I have a link in here because I use this one many times. I just paste in the program. But anyway, I see he has 2 programs upload here. DLAB number 8. So let me try another one and see if I can open it. I got a syntax error. Okay.
But I upload the C++ code, Mr. Pham.
Yeah, I see that C++, but I load that one up, and then I got an error when that build it. So I will try another, okay? Because this one I load, and now I haven't seen that as an error at all. But now I see that error, so I don't know what happened to your CPP. This is the lab number 8, Mr. Marcelo.
Yeah.
Okay, let's check it out. Oh, found that number 3. Let's check it out and see what is the number 3 here. What it is? Where is the test number? Test number 1 and test number 2. And test 3. See, the first one is you meet the test number. Okay. This is test number 3, but you still say fail test number 1.
Marcelo, you need to copy paste everything the way Mr. Pham had it.
Or if you want to do that, or if not, then you after test title, you have to do it test number equal to test number plus 1. It will take care of the rest, okay? Just keep each test. But anyway, let's say you're looking for number 9, but you got number 7. Number 9, you 4 o'clock, and that. Okay. Okay, anyway, your test it failed. I don't know what it failed, where it failed yet, how it failed. I have to look into it. Okay.
Okay. Thank you.
So it's
First thing you have to understand, fix one by one. First thing they missing the test number. They have to fix that before you can do anything else.
That's right. So you have to go back and then correct your test and upload again.
Okay, I'll do.
Okay.
Hey, Marcelo, just as a helper, on the Excel where Mr. Pham put test 1, when you get ready to do test 2, copy test 1 and then change everything on that test for test 2. Then do the same thing for 3, 4, 5, and so on.
Okay, got it. Thank you. I'll do.
Okay, try to load Adam program again.
Yes, we'll load that one again.
So again, the way that maybe I'm wrong, but the way that I was understanding was that when we already have serialized data to bit 1, we have enabled U3, we have clocked the data into U6. If we write 0x21 to port B, that will enable U6 output as well as enable U7 to pass the data through to port C.
Okay, I'm telling you why. Okay, so let's see where.
And then the only time you would need the function enable U6 output is when you're writing data to the memory. Because then you don't want U7 to be.
That's why I'm telling you. Okay.
Let's say it's a U7.
Go to tab number 3, right?
Yes.
Yeah, it's this one is say that U6 and U7. It's a function. Okay, let's go back. But anyway, let's run it, view it, and then go back to test number 3. Here is the test number 3. You are going to call that function with the data 55. That's all. So everything should be defined by U6, U7 procedure function right here. So look like the same thing. If you are going to perform this.
No, he
and enable and U3 clock.
Comment now C with a U6 output enable.
Because it seems redundant.
Serial.
Now, right now, test number 3, right?
Yeah, it failed test number 3. Right now,
Go to test number 3.
That is a test number 3.
Okay, so you say you call the function test U67, right?
That's right.
U67.
Okay, now I go to the U67. This one is the function U67.
Okay, so he U6, U7.
And so here was my other question about it was, if we did need to use U6 output enable, it would make more sense to use U7 output enable rather than to write to port B 0x21, because we already have a 1 at port B pin 1. So why are we writing that again?
The thing is, when you say U6 enable, you're not just supposed to get 2-1.
No, you get 0-1. 0x01.
Exactly.
Right.
Only 0-1. If you want to test for the U67, then now you need to write 2-1. The thing is, when you write to the port B 2-1, you wrap around U output U6, U input of U7.
Yes, sir.
Okay. However, when you try to using U6 enable, that means the data go into the memory for the data. You don't want to wrap it around.
Right. So the only time we use U6 output enable is when we're writing data to the memory.
Right. You only write.
But we're not.
You only writing U6 wrap to U7 2-1.
Right.
When you test U6, U7.
Right. And that's what we're doing here. This test doesn't involve the memory.
Right now, I'm looking for U6, U7. Try to see what's going on. U5, U6. U6 output enable only 0-1.
And that makes sense because we don't want that data to wrap around to U7. Right. But when we're just sending the data from U6 to U7, U6 output enable just seems like an extra redundant step, because the very next thing we do is write 0x21 to port B, which enables both U6 and U7, which should let the data flow.
Okay, I think right now, right here, let's say because it's common output,
yeah,
U6 output enable, you have to put this one back. Okay, and then I will recompile and run that again. Again, that is the difference. Okay, rebuild. Because you command that one out. But I don't think if you command that one out, so that it failed. You have to put it back.
Okay, I will stand corrected if this passes.
Yeah, the thing is when you command out U6 output enable, so input U6 cannot be loading to the output.
That's right. That is the right one.
But it does when you write 0x21 to port B. That enables. No?
No. Don't do that way. The thing is, they will be going at a different time.
Okay.
That number 3 fell again.
Okay. Is it your hardware? It's okay or not okay?
Yeah, the hardware has been running.
I think it's the hardware. You want to run mine and double check?
Yeah, run a different hardware on this, a software, and see what happens.
No, I run a different software, okay?
Yeah.
But okay. To make sure that one is still okay. Okay, yeah.
Run Mr. Smith one. That one passed.
Hey, Mike, you don't want to do it, man.
Why not?
I'm scared.
You passed it last week already.
I know, but this is this week. Hey, Adam, last week was last week. This week is this week.
Yeah, you never know, man.
Yeah, I know.
Adam, I tried it on mine and I just comment out the U6 enable. It's still running.
Oh, so that is something it failed now.
Ah, on two different programs.
Yep. Wait a minute. Let me check and see my hardware. Okay.
Okay, you're going to have to get your multimeter out.
No need to.
Just reset it.
It's just connect and reconnect some of the port, that's all.
You need to press the reset the box.
Yeah, I will. Just make sure it's on up the port here. Connect it correctly.
Hey, Mr. Pham, you know what? Since we've been doing things this way, when you get back in the lab, you won't be able to tell, huh?
Okay, here we go again.
And this seemed like the same thing to me. When we write 0x, I believe it's 23 to port B,
No,
that will allow the memory to be read simultaneously as it enables
This is the lab number. Oh, wait a minute. What is this? This is the lab number 8. No, I put in the lab number 9, sorry. Oh, this one is number 9, right?
9, this is right.
How come it's got HFAM on there?
No, you're talking about number 9 or number 8. We are
number 9.
Number 9, right?
Yes.
Oh, sorry. I wanted to leave my number 8 hardware in there.
All right, let's do it again.
Okay, we'll check it quickly.
The one on the screen got HFAM on there.
So I will put this Adam program pack.
So like I was saying, I thought that this would work in the same way that it's actually 0x32 that we write to port B to allow the memory to be read and simultaneously.
So now the Adam program back here, okay? You still see my sharing window, right?
Yes.
And the U6 output enable original is command out.
Okay.
So we're going to run. This is original, run it again, okay? To make sure that one pass or fail before we release enable the U6 output enable function again. Now run with the original. That number 3 fell.
Okay. Now you got to take the
U7.
out.
Okay. So now just
use
stop it.
Your program.
And I enable this. I put the U6 output enable back.
And you run it again.
I rebuild. Okay, remember, this is the run the test program with the U6 output enable.
Yes, sir.
It's going to work.
We'll see.
Think it will.
Okay. Nope.
Nope.
Can
it
you
felt
use
same thing.
I think it's the hardware.
It found a different data read back, but it failed.
So your hardware working or not?
Okay, now I have to put the hardware at the new at DLAB9 to check the hardware. Okay.
So it's realizing.
This is DLAB number 9.
Whose hardware is this? I mean, software.
I believe mine.
Okay.
The thing is, when they build the circuitry, I get my program already working. Okay.
Okay.
Go back to hit program.
Okay, now we stop now. And come back here, I say Control Z. So that is, I go back to your program.
Okay, let's see.
Adam.
Go back to the
test number 3.
That's number 3.
No, I think everything is test number 3 is they call this function, that's all.
Okay, yeah.
Okay, now. Okay, let's see. Let's see. First thing, they go enable U3. Okay, then they call U6 clock. And they call output, U6 output enable. Okay, then they try to port B to 1. Okay.
Yeah, that's the same thing.
2, 1. Okay, then go back to test number 3.
Okay, go back.
Function definition of serial ladder to bit 1. Void serialized data to bit.
That is the only thing on number 3 is that they call that U6, U7.
Yep. That's the same as mine.
Okay, now what we need to do is comment that 87.
87 comment.
So we're not going to call this.
Right, comment that out. Okay, now adding the code. You copy from the U6, U7.
That's right. That is what I'm going to do. Is I just put that definition go back in here. It's before we're doing this. Okay, I'm going to copy this.
Right.
The whole thing, copy and then go back to the test number 3.
Are you going to, he putting it directly in the program?
And then,
right, that's what I try to do.
Because as I understand it, when I'm looking at it, I say, oh, that should be the same thing. But it's only thing that he put it in the function. That.
Okay, so serial data will be 55.
Zero X55, ain't it?
0x55.
Okay, rebuild. We run again. Okay, that number 3, okay. That number 4 failed. Now U6, U7 again.
Well, test number 4, I used test D6U7 as a function.
Yeah, that means something must be wrong.
Now, can we try something, Mr. Pham? Go back to the test number 3.
Okay. So now I want to change this to the number 4.
No. Just comment out U6 output enable.
Line 91. Yeah.
Comment that out.
Comment it out?
Yes. Line 91, yeah. And build and run it.
Okay, you try to see without that, it that work, right?
Yeah, it's still working.
Yes, it should work, yeah.
Yeah, because it's a right for B21 in there.
Exactly.
So what went wrong? I don't understand what happened.
What do you mean? Something wrong in your depth?
In your function,
yeah.
Maybe you did a alt or
The
control.
thing is, sometimes you see it, they look like the same, okay? However, they will be different in the binary, you never know.
So I bet you, just like you passed number 3, where you added the serial and enable the U6, put all of that in number 4, and number 4 should pass.
Right.
That's right. That's what I'm going to say doing here.
I'm very confused. So is it something I did wrong?
He said, do not get it wrong. But what I say on the function definition, U6, U7, you see look like the same. However, they must be wrong in the binary. You see the alpha beta look like the same, but the binary is wrong.
So
If
basically,
you want to try, you have to remove that, delete that, and try to make a new one.
Yeah, to retype it, sometimes that should cure it, because when you type it, sometimes you might hit a control or something.
Yeah, I agree with that, Mike. You might have hit it by accident.
No, that number 5. Did I change it? Let's check and see. That number 4 I put in AA, but it read 55.
Maybe when you copy paste,
When you go a serial, they have to be AA, right?
That's right here. That number 4, I just changed it.
Okay, then you enable U3, right?
Yeah.
U6 clock.
Yes, and then comment out that.
Line 111. Remove the comment.
What do you mean?
Line 111, remove the comment.
Where is comment out?
Line 111, 111. Take the comment out.
Line 111.
Which one?
111, 111, 111.
What line number? Tell me.
111. 111. Yeah, 111.
Yes. So you want to enable this?
Take the comment out.
They must be enabled.
And why? You see that number 3, the comment out, it work?
Now, the thing is, U6.
See, that number 3 here, comment out, it's working. And this one just a change in your data.
I'm very confused.
It doesn't make sense. Okay, anyway.
It should work.
I run it one more time and then we're done for tonight.
I feel like it should have worked the first time.
Hey, Adam, sometimes you got to, like Mike said, you might have to copy, paste, and play with it because it might be something that got hit by accident.
What I'm saying is what you see in the program is not a real binary. So
it still failed test number 4.
If you want it, then you have to delete the whole test number 4. Copy test number 5, number 3 to 4, change the data.
So copy the whole test number 3.
Paste it to make a number 4. Delete a whole test number 4. No.
That is number 3.
Yeah,
Copy. Copy.
Okay, then delete number 4, everything.
And now number 3 change to number 4.
Yeah.
Okay, data change to file AA. And enable 180. Or you don't want it, that's okay. Try to compile.
Okay, so review and run it one more time.
Okay.
Don't know. It looked the same, but when it run, it fell one and then passed one.
I got the luck of the Celtics right now.
That means they lost, right?
I'm not sure, but I bet money they did.
Okay, number 4, come on, pass.
Still fell. That's number 4.
Man.
What?
So what round? It's reading. It's still reading number 5. It's reading out number 5.
Okay, going back that number 4, see what's going on. That number 4.
Hardware.
Okay.
It's the same.
Serial. Enable E3. E6 cloud.
Should be the same as
And now,
S3.
take the comment out of the line. E6 output enable.
109. 109.
109.
So
Take that out.
Okay, compile and run again.
oh.
Oh, come on.
Come on.
It has to be hardware.
Hey, Mr. Pham, can we do one last thing? One last thing.
Wait for me. I'm checking the one. I think it maybe cause a problem here. No, that is the same thing. It's nothing else in here.
Yes,
Right?
you wouldn't have passed if something was wrong with that.
So that number 4 and that number 3 and number 4 identical, just a different data, but it's written the same data 5. Okay, so
you can try my program one more time.
Yeah, that's what I was going to say. Yeah.
If it's working, then we have to need to look in later for his program. How come?
Hey, Adam, if Mr. Pham's work, then you might have to redo yours.
Just rewrite the entire program?
no, just a few tests.
Maybe a few tests only.
All right, because it compiles on my side, so I can't tell where the mistake is on my side.
Yeah, you're really good at this, Adam, so I don't know why it failed. Oh,
it passed.
Oh, man.
Oh, man.
I don't understand it.
I'm really confused.
Yeah.
Okay, so
you know the problem is that Mr. Pham been an engineer for 50 years, so you know his is going to pass.
I will looking back into your program tomorrow, and we'll see what happened.
Okay, thank you very much.
But you also, because you want to do that way, so looking back and see what you think you can do, okay?
Okay.
Good night.
Until now, I still don't know how. Why?
Okay, we'll figure it out.
I stop sharing now, and then I check on it tomorrow.
I have one last very quick question regarding
Yes.
signing up for summer semester. What do we do? Did we already get our permission numbers? Do we need a permission number?
Adam, is it Adam Pudding?
Yes, sir.
Okay, let's see. I try to see what their name, what your class.
The mystery will have to wait until tomorrow.
Yeah, I still not quite understand.
That makes both of us.
Right here. Okay, let's see. Your permission 501525.
Okay, thank you very much.
And your class. That means your class will be a 62020.
62020?
Yeah, 62020.
Okay, thank you, sir.
The thing is, you know, in your program, if I get a hardware, then can find out easier. The thing is, we have to using a debugger. So that's why we run it. We go line by line. Then we can find out what's wrong.
Hey, Mr. Pham, just to real quickly to iterate on that, just like you're saying, usually you have to use the debugger because your program worked and we tried all that different stuff and we pretty much sure that the hardware worked. So it's something in the way that the program is written where the debugger can possibly help us fix it. Is that correct?
Exactly. If we're using the debugger, then I can know, what the data they write to.
Mm-hmm.
Okay, step by step.
Yeah, because you're saying internally,
right.
there's something in Adam's program that's different.
Right. Sometimes you see your coding, you see nothing wrong. But what I'm saying is, when they converting to the binary, that is wrong.
Okay.
Okay. So only the debugger able to tell you.
Okay. Thank you very much for taking the time.
Okay, I will be teach your guy debugger. Okay. However, right now we're still on the process to get along with the software. When you already know it, then I can teach you. And Adam, if you want to learn it, I can teach you. The thing is, that not apply for everyone. The process get through the program, they still get a problem. I don't want to confuse it. Okay?
All right.
Yep, sounds good.
Yeah. We'll see you guys tomorrow.
Thank you very much.
Yeah, no problem.